Welcome, programmers! This video mainly covers the if and else if statements. I'll also cover a little bit of structured programming and how to debug a program. As far as structured programming goes, programs are organized into modules, also known as blocks of code. Each block has one entry point and one exit point. Within each block, code is organized using three constructs and no go-to statements: sequence, selection, and repetition. Before we had structured programming, code was also called spaghetti code because we had go-to statements. Go here, go do something, go over there, do some more code, go over there. When we went there a little bit more, and go back over there. What follows after structured programming is object-oriented programming. That will be covered somewhat later. It builds on structured programming and includes structured programming. Here are the three constructs: sequence, selection, and repetition. Sequence, all that means is we do steps in a certain sequence. Sometimes it really matters what sequence you do the steps in. Other times it doesn't matter too much. For example, if I was baking a cake, some of the things I have to do is collect my ingredients. For example, I might have flour, egg, water, and maybe something else. And what I have to do is mix them all up, grease the pan, pour it into a pan, put it in the oven, and bake it for 20 minutes or whatever, and take it out, let it cool. Well, how about if I messed up the sequence? How about if I collected all my ingredients, I put the egg and the flour and the water in the pan, stuck it in the oven, pulled it out, and then I mixed everything up. That's a big glob of goo, right? As far as selection, let me give you a couple examples. If I'm working with an ATM machine, I might have a test right at the beginning. Is the passcode or the PIN number correct? If it is, go ahead and do the processing. Otherwise, bail out. Furthermore, in the ATM machine, here's an if else. I have to make a decision here. Is this going to be a withdrawal where I'm giving out some cash, or is it going to be a deposit where I'm taking money into the ATM machine? Repetition. This is where we're going to do a loop. We're going to do some code, loop back, do it again, loop back, do it again, loop back, do it again. Eventually we'll have to break out of the loop. On a do while loop, we're going to do the test at the bottom to decide whether or not we keep looping. With a do while, we're going to guarantee that we're going to do this code at least one time and then make a decision we want to go back and start repeating the code. The only difference between that and the while do is the while do, we're going to make the decision right at the top of the loop. Do we even want to execute this code? So maybe we don't even ever do it at all. We just completely bail out. There's also a for loop, which basically all that is a fancy do while loop. And all that stuff has to be covered in a different presentation. Here's an example. I'm going to look and decide whether or not I want to put out a message that says, great job. So if somebody got a score of 90 points or 90% or better, I'll put out a message that says, great job. If they got like 85 or 75, they just don't get that attaboy that says, great job. How about a different scenario? At the DMV, I'm assuming, let's say the DMV, you have to get a score of 70 points, 70% or greater. So we're going to come down here, and here's my score, and I have a variable, a string variable named message. If the score is greater than or equal to 70, I'm going to set my message to you passed. Otherwise, I set the message to try again. So the Boolean expression right there is going to compare score to see if it's greater than or equal to 70. That evaluates to either true or false. So if somebody gets a score of 50, the message says try again. If they get a score of 73, the message says you passed. We also have an if, else if, else if, and you can do a whole bunch of those. If, else if, else if, else if, else if, else if. And finally, we would like to have an else all the way at the bottom. So right here, I have an if and a Boolean expression. If it's true, I do one thing. And else if, then here's another one I test. If it's true, I do something. Else if, here's another test. If it's true, I do something different. But in any one of these cases, if any of these pass, then I don't keep on going and testing for the rest of the stuff. So, for example, I was looking at a grade. If my grade was 90 or greater, then I'll say A. If it's at 89, then I'll say B. I can even say if it's 90 or greater, it's an A. If it's 80 or greater, it's a B. If it's 70 or greater, it's a C. Well, see what's going to happen if somebody gets like an 85. Is it 90 or greater? No. Is it 80 or greater? Yes. The grade's a B, so then I'm going to fall down and I'm going to skip the rest of these conditions. I'm not going to do any more else ifs. What happens if I have something where nothing passed? That's where I'd like to have a final else. That's called a default condition, and I'll say like it's not a legal score. In the rest of this video, all I'm going to cover is the information for the if, else, and that's the code here that's like in the box. You can take this code and stick it in a C++ program, a C program, or a Java program. The code and all of the syntax for the if, else is exactly the same for C++, C, and Java. What's different is going to be at the top, how you get the program started, and at the bottom, how you display the message. Syntax of the if statement. In pseudocode, I'll just say if condition then, and then a statement, and then indef. If you're used to Visual Basic, Visual Basic is very close to the pseudocode. In C or C++ or Java, I'm going to have, it's going to say something like if, and my condition is going to be in parentheses, and then a statement with a semicolon. This is an if with only a single statement. My sample program, if score is greater than or equal to 70, message 1 equals, quote, you passed. Here's the compound if statement. If there's more than one statement that I want attached to the if, I have to put it in a block of code, starting with the open curly brace and closing with the closed curly brace. So here's my sample. It says if score is greater than or equal to 70, message 1 equals congratulations, message 2 equals you passed the written test. I need that block of code to tie both of these statements to the if. The syntax for the if, else. Here is my if, and the condition is something that evaluates to true or false. So here's my if, and then statement 1, else, statement 2. So I can say if score is greater than or equal to 70, message 1, you passed the test. Else, message 1 equals try again. Then later on in the program, I need either like couts or printfs or something to display that message, right? Otherwise, it'll just sit in the program, won't go anywhere. Here's the compound if else. Remember, I need those curly braces to create a block of code, so then I'll have more than one statement hooked up to the if, and I can have more than one statement hooked up to the else. So if score is greater than or equal to 70, congratulations. Also, you passed the test. Else, sorry, try again. I am going to create a program. I call it like a code fragment, because this is what you can stick inside of your Java program or your C program or C++. This code is going to be exactly the same. It doesn't matter whether you use Java or C++ or C. Here it is. I'm going to test the score. 90 to 100 is an A, and also put out a message saying outstanding. If the score is 80 to 89, I'll put out a B and I'll set the grade to a B and put out a message that says exceeds expectations. In this example, I'm going to be using an integer for score. That means it has to be a whole number, right? I'll say if score is greater than or equal to 90 and score is less than or equal to 100, grade equal A. So the only thing right now I'm doing is setting grade. I'm not doing the message yet. If score is greater than or equal to 80 and score is less than or equal to 89, grade's a B. Okay, so here we go all the way down, and I think I have pretty much covered everything that is in our definition, well, except for the message. How about setting it up like this? If score is greater than or equal to 90 and score is less than or equal to 100, grade equals A, message 1 equals outstanding. If score is greater than or equal to 80 and score is less than or equal to 89, grades B, message 1 equals exceeds expectations. Actually, I want to run this program. I'm going to put it in just like the way it is and just see what happens. How about if I get a score of 85? It's going to say grade equals B, message equal 1, say dreadful. What happens is this first if statement does not pass, so I'm not going to set grade equal to A. But this message 1 is not inside a block, so that's totally independent from that if statement. It's going to set message 1 equals outstanding. Then I'll say if score is between 80 and 89, grade is equal to B. Also do this message 1 because it's not part of the if statement, and I'll say exceeds expectation. How about right here? Here's the next if statement. If score is greater than or equal to 70 and score is less than or equal to 79, which is not true, so I don't set grade to a C. But since message 1 is not part of a block of code hooked up to the if statement, I'll set message 1 to acceptable. And I'll keep on going all the way down. And here it says if score is greater than or equal to 0 and score is less than or equal to 59, well, that's a false. So I'm not going to set grade to equal to F. But this last one where it says message 1 equal dreadful, that is not hooked up to the if statement. So it's going to eventually set message 1 all the way through, and the last thing it does is it sets message 1 equal dreadful, and even though if I have a score of 85, it's going to say dreadful. It's not too good. So what I can do is make sure that I have blocks of code here. So that way, if somebody gets a score of 85, this first one doesn't pass. The second one does pass. I'll set the grade equal to a B. Message 1, say exceeds expectation. The third if does not pass. The fourth if does not pass. The fifth if does not pass. So this way it's going to say grade is a B and the message 1 is going to be exceeds expectations. What we have here is our tests. The first test is going to look for anything between 90 and 100. The second test is between 80 and 89. The third test is between 70 and 79. Then we have a test between 60 and 69 and a test from 0 to 59. Now, instead of using an integer, I'm going to use a double. With integers, my score has to be a whole number. But with a double, when I'm reading the score, I can read in like 85.2 or 78.9. Okay, how about if the score is 89.5? Here's my if statements. 89.5, remember? If it's between 90 and 100, it's not true, so I'm not going to get an A. If it's between 80 and 89, that's not true either because it's really 89.5. So I don't get a B. Is it between 70 and 79? No. Is it between 60 and 69? No. Is it between 0 and 59? No. What happens is when I'm using a double, the way this code is set up is I have holes in between 89 and 90. I have another hole in between 79 and 80, another one between 69 and 70, another hole between 59 and 60, because like right over here, I could have like 79.3, but the C only goes from 70 to 79. But if I have 79.3, it never matched any of my tests. What I'd like to do is to update my program to make it a little bit better. So now maybe I can just code this up myself, or depending on how things go, you might have to go back to whoever set up the definitions for the project and see if it's okay. How about if I set it up like this and just change the requirements or change the way I implement my program to say 90 or above is an A, 80 or above is a B, 70 or above is a C, 60 or above is a D, and anything greater than 0 is an F. This way, if somebody has extra credit and they have like 110 points or something because they did extra work and they ended up with a total that was more than 100%, they can still get an A. The old way, if A is between 90 and 100, if you get 110 points, then you don't get an A. This way, you do get an A. What happens if you have a negative score? How about changing the way I do things? So now anything from 90 and above is an A, even if it's 110. Anything from 80 and above is a B. But see right here is if you get an 80, 85, it's going to be a B. Is that going to be an A also? Well, no, because I'm using this if, else if, because if, else if. Right here, once it's an A, I'll say grade is equal to an A, and then I'm bailing out of that if else, if else, if else, if else. And I won't do any more tests to see if it's greater than 80. The only time I go and look to see if it's 80 or above is if the A did not pass. Okay, so what happens with a negative number? I want a final else down here, and I'll put grade equals question mark message unknown. How about if I have double score and I have 89.6? Is it greater than 90? No, 89.6 is not greater than 90. Oh man, I got so close to an A. That was horrible. Okay, is it greater than 80? Yes, to get a B for 89.6. Okay, so then once I hit that 89.6, I set grade to a B, say exceeds expectation. I'm going to skip all the rest of this code. And right here's my default for anything less than 0. Okay, now if somebody gets their 89.6, is that close enough to an A? Yeah, let's be generous and say, okay. What happens is I can read the score in and then add 0.5. So now an 89.6 becomes 90.1. And then they'll get an A. How about if I have 89.4 and add a 0.5? Then it becomes 89.9 when I do my test and they still get a B. Let's look at debugging the program. I'm going to have two different ways to debug the program. There is the old brute force method of when the program is running, I'll just add an extra output message, cout or printf in there to display, okay, I got this far, and then I got that far, I got that far, and I got that far, and here's some of the stuff. That's a crude way of doing it, and there are many times where I didn't have a good debugger, and that's the only thing I could do. The better way is if you have a good debugger. You can set a breakpoint. Now, what a breakpoint is it says run the program all the way to this instruction, stop, and then You can look around at the code. You can look around at what your variables are and how far you got and what the score is or whatever. You can do a step, which means do one more instruction, do one more instruction, do one more instruction. There's something called continue, and that says just keep running the program until the end. So once you hit that breakpoint, you can either step or you can say continue, and it's going to run to the end, or it's going to run until you hit another breakpoint. So you can set multiple breakpoints in your program. Say stop here. Look, here's another breakpoint. Stop here. Okay, look around. If you have another breakpoint, stop here. Or if you don't have any more breakpoints, and it's going to run all the way to the bottom. I hope all of this makes sense, and check it out. Don't just look at the video. Maybe you want to look at it a second time and actually go and take the code. I'm going to provide the code for C++, for C, and Java on my website. That way you can take that code, stick it in, and run it. And now if you do this, remember that you need to start a new project each time you start a new program. Okay, bye-bye for now, and I'll see you next time.